Hi, my name is Sanjay Narvekar. I'm a product manager in the Oracle Cloud Infrastructure outbound product management team. In today's lesson, I will be covering the migration concepts for migrating infrastructure as a service workloads from Oracle Cloud Infrastructure Classic to Oracle Cloud Infrastructure. The objectives of this lesson is basically to educate you on the benefits of migrating your workloads from OCI Classic to OCI, and it'll also give you the key considerations that needs to be taken into account when you look at migrating workloads from Classic to OCI, and also the migration strategy along with the tools for migrating infrastructure from OCI Classic to OCI. So basically, the lesson is carved out into these five sections. We'll look at migration considerations, then move on to migration tools, and then briefly look at what migrating users and groups entails, and then look into creating the virtual cloud network in OCI, and then finally look at the virtual machines and block storage migration from OCI Classic Compute to OCI. Let's get started. Let us now look at why customers should consider migrating their workloads from OCI Classic to OCI. The OCI infrastructure has differentiated capabilities for enterprise applications and databases. It gives predictable storage and network performance, and we do this by providing consistent IOPS and throughput for block storage regardless of volume size. The network is non-oversubscribed and non-blocking, and we provide SLAs for storage and networking performance. We offer bare metal shapes and virtual machine shapes in various configurations, and it also includes the latest CPU and GPU shapes. And we allow customers to deploy highly available and disaster recovery deployments on OCI, and we do this because of the multiple availability domains architecture and the localized fault domains architecture within each availability domain. We have strong and broad SLAs for performance, availability, and manageability in OCI. Also, we provide improved governance and security, and customers can run their Oracle workloads on autonomous transaction processing and autonomous data warehouse. Using the single console, they can provision these services as well as manage their autonomous services. We also have edge services such as DNS, web application firewall, email, DDoS protection, and approximately we have about 25% savings per OCPU hour moving to equivalent Linux OCI shapes from OCI Classic. And we also offer customers container service, streaming, monitoring, resource manager, and other OCI services which are not available on OCI Classic. In this slide, we'll look at the considerations for migrating your workloads to OCI. You need to take into account the current technical expertise you have in-house, as well as timing and downtime expectations, along with the business constraints for the different applications that you're running in OCI Classic. And you then look at the environment information. Are you running dev, test, or production, or a mixture of these workloads in OCI Classic? What kind of subscription type do you currently have on the OCI Classic infrastructure? Are you using non-metered, metered, or universal credits model? Where is the data center located currently for OCI Classic? And is an OCI data center available in that same region, or do you need to be migrating your workloads to an OCI data center which is not in the same region as the OCI Classic data center? What kind of services are you using? Are you using IaaS only, or a mixture of IaaS and PaaS? And are you using any lift and shift applications such as Oracle, Apps Unlimited, or Fusion middleware? Here are the network considerations for migrating your workloads to OCI. You need to consider general network requirements, what kind of network security you need to have in place for your applications. Will you be connecting your OCI classic environments to OCI as you work on the migration of your workloads? Do you currently have a VPN or fast connect service configured from your on-premises to Oracle Cloud Infrastructure Classic? Let's now look at the database considerations for migrating your database workloads to OCI. You need to first create an inventory of the number of databases you're looking to migrate, the purpose of each database, application dependencies, and average size of each database. For all Oracle databases, you need to list the type of database deployment. Are those databases deployed on platform services or are they deployed on infrastructure only? What's the version and edition of each database? Then you create an inventory of third-party databases that you are deployed on OCI Classic and list out the brand, version, and edition of each third-party database. You'll then create a migration method for each of these databases that you're looking to migrate from Classic to OCI. And depending on the targets that you're choosing for Oracle databases, you may have to adopt a different migration method. From a choice perspective, you can deploy Oracle databases on infrastructure as a service only, or you can deploy it on PaaS service, namely DB systems, autonomous transaction processing, autonomous data warehouse, and Exadata cloud service. When you look at migrating your virtual machine workloads to OCI, there are quite a few factors that you need to consider. How is access to the instance secured? Are you using SSH for Linux, remote desktop for Windows, etc.? Are you using a Bastion host to connect to your instances? How are you currently patching your system? And is there a way to audit the fleet of virtual machines for patches? Are you running any malware or antivirus software on your infrastructure? How are system level logs captured? Have you done any hardening on your servers? What kind of monitoring is in place currently for your servers? Are firewalls running on these instances? And does the system sync time using NTP, etc.? So all these need to be captured, and you need to address some or all of this as you migrate your workloads to OCI. Let's now look at the block storage and custom image considerations for migration. From a block storage volumes perspective, you need to verify if the performance that is provided by the OCI block storage system is reasonable for your workload. Verify the block volume backup plan you currently have and map it to a backup plan that you're going to put in place in OCI. When using iSCSI, we recommend you enable CHAP authentication for security purposes. Be aware of limitations, namely size, reserved IP addresses, whether the instance is Windows image or not when you're looking at migrating custom images from OCI Classic to OCI. Since images can be shared across regions in OCI, you just need to upload your image only as needed for startup time. Let's now look at application level disaster recovery considerations. You need to account for how the application is accessed from your on-premises location? Are you using a DNS fully qualified domain name, or are you using public IP addresses directly when you access your applications? Will a failover between production and disaster recovery be accomplished by making DNS changes? Are there any other IP requirements between DR, prod, and any other environments, or are these largely undefined, non-existent? Then you finally need to compile a list of all applications that you will be running in OCI environment and specify where each application currently resides, whether it's running on premises, OCI Classic, or other cloud providers. This is especially needed if you have a hybrid cloud architecture in place. Let's now look at the OCI Classic to OCI migration process. The first step involves discovery, where you will discover all the resources that you're running in OCI Classic. And these resources can be networks, the security rules that belong to this networks, the storage volumes, the instances, etc. You will then go through a mapping exercise where you will map your OCI Classic network and security definitions to a corresponding virtual cloud network on OCI along with its corresponding subnets and security lists. You'll then migrate your compute instances and data volumes from Compute Classic to OCI Compute using a tool. And using a tool, you can also generate a Terraform script to create target VCN and launch migrated instances. This will give you a picture of what a migration process from Classic to OCI looks like. Customers need to look at migrating IP networks, any load balancer services that they're currently running, security lists that map to the IP networks, any fast connect services that they are currently using, along with routes belonging to the networks, and if any VPN services is being used, and then finally the data volumes along with the virtual machines which will have to be migrated over to corresponding objects in OCI. In OCI, a network is called a virtual cloud network, and it has subnets in the virtual cloud networks, and we have load balancers and corresponding security rules and routes belonging to the virtual cloud networks, along with VPN, DRG, and LPG, which stands for Dynamic Routing Gateway, and Local Peering Gateway, which allows connectivity between networks, and also we have virtual machines and block volumes. Let's now look at the migration tools at a high level. The discovery and translation tool is used for discovering the resources running on OCI Classic. It will also allow you to do analysis and reporting of the source environment details, and enables mapping of Compute Classic network configuration and security rules to OCI virtual cloud network. It also lets you export Compute Classic instance and storage volumes details necessary for migration, and this list can be used as an input to the VM and block storage migration tool. And finally, the discovery tool also lets you generate a Terraform script for VCN creation and launching of migrated instances. We then have the VM and block volume migration tool, which basically copies VM boot and attached storage volumes from Classic to OCI. The boot volumes are first converted to OCI custom image, which is then used to launch new instance from. Storage volumes are converted to OCI block volumes on the OCI side, And the migration jobs are basically managed by the migration control service. One is called the controller server, which runs on the source environment, which is the OCI classic environment, and the other is the control T or control target server, which runs on OCI. And these servers will have to run on the customer tenancies. The migrated instances can either be manually launched from the console or created using the generated Terraform scripts. In the previous slide, you saw how the block storage and VM migration tool can be used to migrate VMs and attach storage volumes from OCI Classic to OCI. If you want to migrate data volumes which are not attached, or you want to migrate data volumes without migrating the boot volumes, you can also consider using the block volume backup and restore tool. Using this tool, you can restore an OCI classic volumes backup to an OCI volume. Once this volume is available on OCI, you can attach that volume to an OCI VM or convert to an OCI backup. The tool allows you to create automatic volume creation in the chosen availability domain, and restoring backups to different availability domains can be done concurrently. It facilitates asynchronous operation with the ability to monitor job progress. Backup conversion takes place in an OCI compartment that is isolated from the customer's workload. If you're looking to migrate Oracle databases from OCI Classic to OCI, you can consider using the database backup migration tool. This tool allows you to migrate OCI Classic DBCS instances, which can be single node or rack, to OCI. How this works is it creates an RMAN backup of your OCI Classic DBAS instance and automatically transfers the backup to OCI object storage as a standalone backup. And this backup can then be used to create a database system in OCI. Note that since the database in your source OCI Classic environment needs to be shut down for your RMAN backups, this method may not be feasible for your production instances. In case you're looking at migrating production instances with zero downtime, you may want to consider using tools such as DataGuard or Golden Gate. And obviously you need to have Database Enterprise Edition to use DataGuard. Let's now look at migrating users and groups. Before you migrate your workloads from Classic to OCI, you need to ensure that your users who were using the OCI Classic environment will have the same set of access and privileges in OCI. So you'll need to go through a process where you list out all the users, the groups, and their assigned privileges, and then you need to map out those groups to a corresponding group in OCI and also assign those groups policies such that the users can access the necessary resources which will be needed for them to do their job. Let's now look at creating a virtual cloud network in OCI. Before you create any resource such as an instance or a database in OCI, you need to first create a virtual cloud network in the OCI. Depending on your application use case, you may have to create one or more VCNs. If your application requires internet access, you will need to create an internet gateway and or a NAT gateway. And optionally, you may have to configure a service gateway for your VCN if you need to access object storage for backup purposes. And you may also have to create one or more subnets in each VCN depending on your application requirements. And optionally, you may also want to use local peering gateways between VCNs if your applications are on different networks and they need to talk to each other for some business process. And depending on how you created your security rules in OCI Classic, you may have to create similar rules in the security list and update the rules in the route table accordingly. You can create your VCNs manually using the OCI console, or you can use the Terraform file output by the OPC Migrate tool. When you migrate your network, some network configurations might change. In OCIC, security rules are applied to groups of VNICs called VNIC sets. However, in OCI, there is no equivalent grouping and security rules are applied to an entire subnet. Let's now look at considerations for migrating your network. When you migrate your network from OCI Classic to OCI, some network configurations might change. In OCIC, security rules are applied to groups of VNICs called VNIC sets. However, in OCI, there is no equivalent grouping and security rules are applied to an entire subnet. You can prioritize your VCN creation in OCI by following two approaches. One is you prioritize the network topology or prioritize the security context. Prioritizing the network topology means that your networks are mapped to separate VCNs and subnets, so you can easily identify your networks and manage your IP address ranges. Prioritizing the security context means that the same set of security rules is applied to each interface. But with this strategy, there is no clear mapping between IP networks and VCNs or subnets. This table shows you the differences between security context mapping and network topology mapping. As I mentioned earlier, security context mapping maintains the security model. It will allow you to apply the same set of security rules to each VNIC in OCI as you had done in OCIC compute. And depending on the source network topology, it can be quite a complex task to map the VNICs from VNIC sets to subnets. And it will also result in a large number of subnets being created with a corresponding large number of security lists. And some parts of this procedure could require manual steps using the OCI console. One disadvantage of using the security context mapping is when you have assigned static private IP addresses to instances on IP networks in OCIC source environment, some of these private IP addresses might change during migration. However, if this is of importance for you, then you may want to go with network topology mapping because each IP network maps to a separate VCN in OCI or to a separate subnet in a VCN. And this will allow you to assign the same private IP address to each interface as you had in the source environment. You can use Terraform to create a network in OCI where you have the network topology mapping put in place. In network topology mapping process, aggregated security rules are applied to a subnet. And this could expose some interfaces to traffic that it was previously not exposed to, as some ports might be open that they were previously blocked. So these are the pros and cons of the security context and network topology mapping. Depending on what you need for your application. You may have to prioritize one over the other and also accept the cons of going with one of these approaches. Let's now look at an example for security context mapping. So in the screen, you'll see two diagrams. One on the left is for OCI Classic, where you have one IP network with the four VNIC sets, and these four VNIC sets are attached to four VMs, and each VNIC set has one or more access control lists applied. Now, if the same topology needs to be created in OCI, how we would go about doing this is you will create a VCN with four subnets, and you will create security lists for each subnet so that the security list corresponds to the security rules in those ACLs that are present in the source OCI Classic environment. So this can be a painful exercise for customers when they have large number of networks and large number of VCNs, because they have to manage each subnet and the security lists that correspond to it, and they can spend quite a bit of time when doing this. Let us now see how the OCI environment looks like when network topology mapping is used for designing the VCN. As you can see in the slide, this results in a creation of a single VCN with a single subnet, which has a security list with all the rules corresponding to all ACLs 1 through 7, and all security rules apply to all VNICs, since all the VNICs are in the same subnet. So this results in VMs 1, 2, 3, and 4 being exposed to the same set of protocols and ports that are opened up in the security list. Let us now look at considerations for connecting VCNs using local peering gateways in OCI. Before setting up VCN peering, consider the following. While VCN peering is an effective way to allow traffic across VCNs, a better solution is to restructure your IP networks whenever possible so that they can be migrated as subnets in a single VCN with a /16 CIDR block. One of the limitations of VCN peering is that local host name resolution for hosts outside the subnet won't work. If you use the security context mapping strategy, given that private IP addresses might change anyway, consider restructuring your network such that VNICs that need to communicate with each other are created in the same VCN or subnet. With this approach, you generally won't need to implement VCN peering. If you use the network topology mapping strategy and you want each of your IP networks to be migrated as a separate VCN, then you might need to adopt VCN peering to provide connectivity across these VCNs. Let us now look at an example for VCN peering. So in this slide, you'll see two IP networks in OCI Classic being connected to each other using an IP exchange. Now, if you want to mimic this in OCI Classic, you will create two VCNs with subnets corresponding to those VCNs, and you'll also create local peering gateways in those VCNs along with the route table entries that will allow traffic to flow freely from one VCN to the other. Let's now look at connecting OCI Classic and OCI networks. This is an optional step. There are two options. One is connecting to OCI from OCI Classic over the Oracle network. In regions where this is supported, it allows for a much faster data transfer because the interconnect is across two shared fast connect routers at 40 gig. One key thing to note here is the two environments must be in the same geographical area, Ashburn or London, and the connection is available only between these specific regions, between OCI US Ashburn 1 region and the OCI Classic US COM East 1 region, and between OCI UK London 1 region and OCI Classic GB COM South 1 region. And the two environments must belong to the same company, and we will validate this when setting up the connection. As a second option, you can connect over IPsec VPN, and you'll set up an IPsec VPN between the IP network's VPN as a service gateway and the VCN's attached dynamic routing gateway, and the connection will run over the internet. And the benefit of this strategy is that the two environments do not have to be in the same geographical area or regions. Also, the two environments do not have to belong to the same company. We'll now look at connecting your on-premises network to OCI network. OCI provides both IPsec VPN and Fast Connect options for connecting a customer's data center to the Oracle Cloud Network. Use of an IPsec VPN site-to-site tunnel will allow customers to use the public internet for communication. Traffic between the customer's data center to the Oracle Cloud Network will be encrypted, significantly lowering the chances of information theft. Fast Connect provides an easy way to create a dedicated private connection between the customer's data center and Oracle Cloud infrastructure. Fast Connect provides higher bandwidth options and a more reliable and consistent networking experience compared to internet-based connections. We will now look at the virtual machines and block storage migration from OCI Classic Compute to OCI. Before you start your migration, consider the following factors that could have an impact on your migration process: proof of concept, boot volume size, etc. The solution requires the following service and roles. On OCI Compute Classic, you'll need the compute_operations role to create the migration controller instance and to create snapshots of the boot and block volumes. And on OCI, you need to ensure that you have policies in place that allow you to read the required OCI IDs from the web console. You'll also need to create an API user who must belong to a group that has policies in place to create the required resources. You also need to plan for the migration. Before you start the migration, you should collect information about the source instances that you want to migrate. You need to generate and have available the required SSH and PEM keys to access the source and target environments. You need to configure the source environment, set up the network in the target OCI environment, and collect information from the target environment, which is going to be needed when you start working on the migrations. And this information will be the tenancy Oracle Cloud ID, the user OCI ID, the compartment OCI ID, the PEM key fingerprint for the API user, and the subnet OCI ID of the virtual cloud network. And before you begin the migration, you need to complete the prerequisites. Once you have all this information, you'll configure the migration tool and then perform the migration of all the virtual machines and block storage volumes from OCI seed over to OCI. From a post-migration task perspective, the following tasks may not be applicable to all customers, and this is also not an exhaustive list. You may have to update your organization's DNS servers with the new public IP addresses for the application servers running in OCI. If your organization uses code migration tools and/or monitoring tools for your application, you'll also have to update them. And if you have whitelisted the public IP addresses of your applications deployed on OCI Classic, you will have to update the firewall rules with the new public IP addresses. This concludes today's lesson. In today's lesson, you saw the benefits of migrating your workloads from OCI Classic to OCI. You also now have an understanding of the requirements, migration strategy, and tools for migrating infrastructure from OCI Classic to OCI. I hope you join me for the next lesson, which will walk you through the migration tools necessary for migrating your workloads from OCI Classic to OCI. Thanks and have a great day.